Section 3.1 is measures of center. In this section, we're going to learn how to compute the mean of a data set, the median of a data set, compare properties of both the mean and the median, find the mode of a data set, and then approximate the mean with grouped data. And this one I'm going to show you how to do on the calculator. Objective 1 is to compute the mean of a data set. Does everybody remember what mean is or what it means, that word? Average. It's just an average value. And how do you find the average of something? You add them all up and divide by how many you have, right? You can think of the mean value as being the balance point of your data set. If these grades were considered weights on a balance beam here, the median is where that fulcrum would be. It's where our data is balanced. Do you remember in an earlier section, I think it was in chapter 1 even, where we talked about populations versus samples? I made a table that looks like this, where we said if the measure was the mean, we used the Greek letter mu for the population parameter, and we used x bar for the sample statistic. This is where we are tonight. We had other measures that we're going to look at later on, like the standard deviation and the variance. We'll do that in the next section. We're not going to do that tonight. So the population mean is going to be represented by this symbol right here. This is a Greek letter and it's pronounced mu. And then this symbol right here is x with a bar over it, and we call it that. We call it x bar. If you're reading somebody's research, their published research, and you see x bar equals a number, you know that you're looking at sample data because x bar is the variable that we use to represent the mean of a sample. If you see mu equals some number, then you know the data or the results that you're looking at are for a population, not a sample. Computing the mean. If you have a list of n numbers denoted by x sub 1, x sub 2, x sub 3, all the way down to x sub n, this symbol right here, this capital sigma, represents the sum of these numbers. Capital sigma means sum, and in mathematics, sum means to add everything up. So the way we would calculate the sample mean is by adding together all of the data values and then divide by how many data values there are. The way we would calculate the population mean is we would add up all of our data values and then divide by the population size. Remember, a capital N was the measure that we reserved for population. A lowercase n is for a sample. We can find means on our calculators using the list as well, and that's what I'm going to show you right now, is how to find the mean on your calculator using the list. So the first thing you would do is you would put your data into the list. And how do we put our data into a list? Stat, enter. And we're going to go ahead and do that together right now. So I'm going to go to my home screen and I hit stat, enter. And I already have data in my list and I'm going to leave it there. So I'm going to put my data in list 2. Then we type in the numbers, 78, 83, and hit enter after every number, 92, 68, and 85. Once we get the data into our calculators, what do we have to do? Go to the home screen. How do I go to the home screen? Second mode. I hit second mode and that takes me to the home screen. Now this part is new. To find the mean and some other things that we're going to be using, we're going to hit stat, scroll to the right to calculate. So we just use this arrow right here that's to the right, and then hit enter, and we're calculating the one variable statistics. Let me write that down. We hit stat. Stat is a button, so I put it in a box. Then I'm going to draw an arrow to the right because we're going to scroll to the right, and then we hit enter, because what we want to calculate are one variable statistics, and the one variable stats is already highlighted as number 1. If you put your data in list 2, you don't have to do anything different here. I did put my data in list 2. Whatever list you put your data in, that's what you need to fill in for this list. If on your calculator, instead of seeing this, you just see one var stats on your home screen, then you need to hit in second and a number where that number corresponds to the list you're going to use. You put your data in. You hit second and then 2, and it puts in list 2. To change the list on your data, you're going to hit second and then the number that corresponds to the list of your data. So if your data was in list 1 and you wanted to put a list 1 there, you would hit second and 1. Oops, but you should have cleared out the list 2. Hit second and 1, and then that changes your data to list 1. I put my data in list 2, so I'm going to delete this and put second 2. And then you just hit enter. Leave the frequency list blank for now. The last example we'll look at tonight, I'll show you what to do with that if we have weighted tables or group data. Then we hit calculate. And what pops up is what's called our one variable statistics. Notice the very first number we see here is x bar. X bar we said was the sample mean. For this list of sample data, this would be the mean of the data. You would get the same result if you would have taken your calculator and added all those numbers up and then divided by 1, 2, 3, 4, 5 numbers. I'll just show you right fast that we get the same thing. On my calculator, if I did 78 plus 83 plus 92 plus 68 plus 85 and hit enter, that gives me the total for my data values, and then I divide by 1, 2, 3, 4, 5. I just hit divided by 5, we get 81.2. Well, when we did it using the calculator, we got 81.2. Why do you want to know how to do this then if that was so easy? Because this has more information that we're going to be needing in the next section. This number right here is our sample standard deviation. You do not want to have to calculate that by hand if you can help it. The calculator does a really good job of doing that for us. This number right here would be the standard deviation, and I only mention it because I've mentioned that word before, but we don't know that yet. We're not going to learn how to calculate it until Wednesday night. This is your sample size. Our minimum value, our smallest value is 68. You don't know what Q1 is, but you will after section 3.3. And this arrow right here means that there's more information below, and we're going to look at that in just a minute. At this point, looking back at our steps, step 1, we put the data into the list. Step 2, go to the home screen. Step 3, run the statistical analysis, and that puts our answer on the home screen if you scroll down to calculate, and then you hit enter. One more time. From your home screen, you're going to hit stat, scroll to the right, and at this screen you want to hit enter. This then is what our input looks like. This would be our input screen, and this would be our output. Some of your calculators may not look like this. Some of yours may just say one variable stats on the home screen. If that's the case, then you're going to have to tell it which list to use. So you would put in second 1 or second 2 for your list. If your screen looks different, after you see the one variable stats on the home screen, put in your list number and hit enter. It just means that you have an older operating system, and there's nothing wrong with it. It still works. It's just that your commands are going to be slightly different, and what you write on your calculator formula sheet should be slightly different from what everybody else writes as well. That's another reason that I want you to hand write out your calculator formula sheets, because they'll be customizable based on what your calculator is. Objective 2 is computing the median of a data set. We're going to go through the same process on the calculator, but let's first talk about what a median is. A median is just the middle value of your data set once your data is ordered from smallest to largest. So if you have an odd number of pieces of data, the middle number will be your median. These asterisks here represent data values, and here we have 3 data values to the left and 3 data values to the right, and this one right here in the middle would be our median. But if you have an even number of data values, here I have 4 data values to the left of the middle, 4 data values to the right of the middle, and there's no data value in the middle. There's just error. How we compensate for that then is we average these 2 middle pieces of data, the ones that are immediately to the left and the right of the exact halfway point. So we take an average of these 2 numbers to get the median. Another option, a question?
So if you're going to do the average, are you going to add those 2 up and then divide by 2?
Yeah, Yeah, the question was, so if I'm doing an average, do I just add these two numbers up and divide by 2? And the answer is yes. Just add the two middle numbers up, and because I'm only adding two numbers, I divide by 2. That gives you your median. Let's look at the data that we have on our calculator from the first example. I have my data in list 2, and if we hit calculate, this is from the previous example with the mean, using that data. You see that arrow right there on my screen? That means that there's more information below. To access that information, I just scroll down, and then at the bottom you'll see the median. MED stands for median. So you go through the exact same steps to find the median as you did to find the mean on the calculator. You just have to scroll to the bottom of the screen to see the rest of it. And later on, we're going to see that we need all 5 of these numbers in section 3.3. This is called our 5-number summary, and we can use these 5 numbers to make what's called box plots. Alright, the example from the book for the median says, during a semester a student took 5 exams. The population of exam scores is, and then we have the numbers listed. Find the median of the exam scores. What's the first thing I need to do in order to find the median? We've got to sort the data. It has to be in order from smallest to largest. Otherwise the median would change depending on what numbers you wrote first, second, third, and what have you. And the median has to be the same thing all the time. So writing down these test scores, what's the lowest one? 68. Then 78, 83, 85, 92. There's 1, 2, 3, 4, 5 test scores. The middle one then will be the median. You see how we have 2 over here to the left of that, 2 over here to the right of that. The median is the one in the middle. In the next example, we're told 8 patients undergo a new surgical procedure, and the number of days spent in recovery for each is as follows. Find the median number of days in recovery. Sorry, I forgot to write that step down. What's our first step? Sort the data. So what's first? 12, 13, 13, 15, 19, 20, 21, 27. Just to double check, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 2 is 4. That means that the 4 will be halfway in between, 4 to the left, 4 to the right. And how we find the median now is we average these two numbers. So what will the median be? Can we do this on our calculator? Do y'all want to do this one on your calculator right fast? We'll skip doing this on the calculator. This one's easy enough to do by hand. And you just go through the same steps that we did before for the mean, and you can find the median. You just have to scroll to the bottom. Here's the steps in your notes for how to find the mean. What's the matter? Okay, then let's do this on our calculator. First thing we would do is we would put our data into the list. Yeah. Oh no, there is no math to do. Oh, you mean whenever you added 15 and 19 and divided by 2? Did you do... Let's talk about calculators right quick. If you do 15 plus 19 divided by 2, what number did you cut in half? You only divided the 19 by 2, you didn't divide the sum by 2. Because that sum is in the numerator, if you're going to do this in one stroke on your calculator, you're going to need to put that numerator in parentheses. So that would be 15 plus 19, close the parentheses, divided by 2. That gives you the correct answer of 17. Another option is to take 15 plus 19 and then hit enter on your calculator. Then the next button you hit is divide by 2, and what it does is it takes that previous answer and divides that by 2, and it gives you the correct result. These calculators are only as smart as you are, and they do follow the order of operations. If you don't put parentheses around the numerator, it's only going to divide that 19 by 2. Not the 15. If you want the 15 included in being divided by 2, you've got to put it in parentheses or go ahead and hit enter and then divide that entire sum by 2. That was a good teachable moment there on the calculator order of operations. I appreciate that. Here's the steps for finding the mean and the median on the TI-80 Plus. Once again, I think what we have handwritten in our notes is probably better because they're leaving out things like how to get to the L1. You need to hit Stat, Enter. Also, they left out the fact that you need to go back to the home screen before you can hit Stat Calc. I know they're assuming you know this, but I don't assume anything. How you go to the home screen is we hit second mode. Then you can hit Stat Calc and one variable stats. When you do this step, if you only see one variable stats on your home screen, remember you're going to have to follow it up with the list number and then hit enter. Objective 3 is comparing the properties of the mean and the median. A statistic is said to be resistant if its value is not affected much by extreme values, large or small, in the data set. The median is resistant, but the mean is not. Let's consider this example because I think it does a good job of explaining what resistant means and shows you why the mean is not resistant, but the median is. 5 families have annual incomes of $25,000, $31,000, $34,000, $44,000, and $56,000. So this is the annual incomes for 5 families. One family whose income is $25,000 wins $1 million lottery. So for that year, their income is $1,025,000. If we're still looking at the same 5 families, before the mean, their average income was $38,000. After they win the lottery, the mean is $238,000 because that $1 million threw up the average. It blew it up. Before the lottery win, the median was $34,000. These are, if you notice, are listed in order from smallest to largest, right? The middle value here is the $34,000 because we have 2 to the left and 2 data values to the right. Once they win the lottery, we then rewrite or rearrange our data so that we have 31,000 for the lowest one, followed by 34,000, 44,000, 56,000, and then we have our million, which is 1,025,000. There's our $1 million baby. Now the middle value is the 44,000 because we took what was the lowest and moved it to the highest, and that shifted our middle over by 1 value. Does that make sense? Yeah, the median changed and it increased, but not by near as much as what the mean did. That one really big number threw everything off. That's also why when you're taking classes and you're keeping track of your grades, if you have all A's and you have 1 0 on a major assignment, it can take your A down to a C or maybe even a D depending on how much that grade is weighted. A 0 is considered an extreme grade and it throws your average off a great deal. Now let's look at how the mean, the median, and the shape of the data set relate. If we have this normal distribution, remember symmetric and unimodal we said is normal. The mean is equal to the median because there's balance there. Those two things will be the same. If your data set is skewed right, we have this really big value that's going to throw the mean off and pull the mean towards that really big value that's in the tail. So the mean would be to the right of the median if we're skewed right. Think of that outlier, just like the $1 million in the example above, kind of acted as a weight and pulled the average up closer to the million. If you have a data value out here, it's going to pull the mean towards it. If your distribution is skewed right, your mean will be to the right of the median. If your distribution is skewed left, the mean gets pulled once again to the extreme value and our mean gets pulled to the left of the median. Remember, the mean is going to go where that large or small, that those extreme values are. So the mean gets pulled to the tails. Objective 4 is to find the mode of a data set. Another word for mode is most. It's the data value that repeats most often. The mode of a data set is the value that appears most frequently. If 2 or more values are tied for the most frequent, and they have to be tied, then they're all considered to be modes. That's where we get our bimodal or trimodal or multimodal data, but they have to be tied. If the values all have the same frequency, then we say that that data set has no mode. In this example, 10 students were asked how many siblings they had. The results, arranged in order, were 0, 1, 1, 1, 2, 2, 2, 3, 3, 6. The results are as follows. Find the mode of the data set. Which one of these data values repeats most often? 1. So it's more common to have 2 kids in a family, because if it's you and your sibling, there's a total of 2 kids. When your data are arranged in order from smallest to largest like this, it makes it easier to spot what the mode is. On your test and on your homework, watch. Some of them may have bimodal data where we have the same number of things. If I would have just had 1 1 and then I had 2 2s and 2 3s, then 2 and 3 would both be considered a mode. We put the mode in as a measure of the center, but that can be misleading because your mode may be down here at one of the endpoints like this is here. This bar right here represents the mode because it goes the tallest, but it's nowhere near the middle of our data set. So calling the mode a measure of center can be misleading, but every textbook I've ever used for statistics always puts the mode in with the measures of center. Mode can also be used for qualitative data, not just quantitative data, whereas the mean and the median are only used for quantitative data. You have to have numeric data in order to calculate the mean and the median, but modes can also apply to qualitative data. So following is a list that makes a list of the makes of all the cars rented by an automobile rental company on a particular day. Which make of car has the mode? If it's hard to see or to spot with it organized in the table here, we could make our own little frequency table, and that would make it easier to spot. So let's list all the different brands of cars. Okay, it's not a brand of a car. How about a make of a car? Let's list all the different makes of the cars that we have here. We have Honda. Here's our table with the make of the cars listed over here. Now we're going to figure out what our count is. I'm going to go through this table and I'll read across, going across and then down. And every time I say a particular make of car, I'm going to put a tick mark for a frequency. We have a Honda, a Toyota, a Honda, a Ford, a Chevy, a Nissan, a Ford, a Chevy, a Honda, a Dodge, a Ford, Toyota, Chevy, Toyota, and Nissan. And the winner is Toyota. Toyota's the winner there. So this would be our mode. And while it may not be as easy to spot looking at the information organized in a table, once we put it in a frequency table, it makes it easier to see what the mode is. But that's how you would do it. You didn't have to use the table if you didn't want to. You could have just gone through and counted. It's easier to skip one if you do that or miscount. Be very careful whenever you're doing your work for your homework or especially on a test. Make sure you get it right. The last objective for this section is Objective 5, and here we want to approximate the mean using grouped data. Sometimes we don't have access to the raw data in a data set, but we are given a frequency distribution. In 2.2 we saw how to calculate the frequency distribution. Now we're going to see what we can do with the frequency distributions. In these cases, we can approximate the mean using the following steps. Step 1 is to compute the class midpoint. How do we find the class midpoint again? It's the lower class limit plus the next lower class limit divided by 2. The midpoint of a class is found by taking the average of the lower class limits and the lower class limit of the next larger class. For each class, we multiply the class midpoint by the class frequency and then add the products together for the overall classes. That's going to give us a total which would be like our sum of x's. Then we divide the sum obtained in step 3 by the sum of all the frequencies, because remember, the sum of all the frequencies tells us the total number of pieces of data that we have. Once you do that, then we can use the one variable stats that we just went through to do grouped data on our calculator. So you would put your data into your calculator and you would put your midpoints in list 1 and list 2 would be the frequency. And what would be different now whenever we hit one variable stats or calc go to the right and then enter, is our data would be in list 1. This would be the midpoints. And then list 2 would be our frequency list. And then we hit calculate. If you see this on your calculator when you hit one variable stats, you just see one variable stats on the home screen, you're going to put L1, comma L2. So for your calculator that does that, this is what you need to do for the frequencies distributions. If you are looking at group data, you hit second one, and then there's a comma button on your calculator. The comma is right above the 7, and then you hit second 2 for L2. So the keystrokes here, this would be stat, scroll over to calculate, and then hit enter. And if you have the older operating system, at this point the way that you get this into your calculator is you hit second 1, there is a comma button on the calculator, and then second 2. And we're going to do this on our calculator. We're not going to go through it by hand. It says the following table presents the number of text messages sent via cell phone by a sample of 50 high school students. Approximate the mean number of messages that are sent. Here's the frequency, here's the classes. The other thing that I need right now is the midpoint. So how do I calculate my midpoint? So we would do 0 plus 50 is 50, divided by 2 is 25. Once you get that first class midpoint, if you know the class width, and for here, what is the class width? The class width is the difference between consecutive numbers. The class width here is 50. Do you see how, because these numbers that I'm grouping, even on this side, if I look at the difference between consecutive numbers, I'm going to get 50. So the class width is 50. Once you have your first class midpoint, you can then get the others just by adding 50 to that number. And 250 plus 50 is 75, plus 50 is 125, plus 50 again is 175. Plus 50 again is 225, and plus 50 again is 275. There's our class midpoints. Now we get our calculators back out. You need a class midpoint for every single class, yes. In our calculators now, we'll turn our calculator on. Let me just start with a clean home screen. I'm going to go into my list. How do I go into my list? Stat, enter. I have data in my list that I don't need anymore, so I'm going to clear it out. I move the cursor up to the top of the list and hit what? Do I hit delete? No, I hit clear. What happens if I hit delete? The entire list gets deleted. Can I get it back? Yes, I can. And for the steps on how to do that, see the 2.2 video. What goes in list 1? What did you just write down in your notes? The midpoint goes in first. So I'm going to put my midpoints in list 1. That's 25, 75, 125. I'll just shut up and type them in, and that way you can type them in. Make sure you don't make a typo typing these in. If you do, it throws everything off. Once you've got your midpoints in list 1, what do you put in list 2? The frequency, and that's going to be 10, 5, and it has to be the frequency that corresponds to these midpoints. They're aligned to where they're equal. So for example, this is the midpoint that goes with that frequency. This is the midpoint that goes with that frequency. Any questions about that? So we go 10, 5, 13, 11, 7, and 4. If you've done this correctly, you'll have the exact same number of numbers in list 1 as you have in list 2. If you don't, you've made a mistake somewhere. Go back and check your data. What do we do now? Second mode. You've got to get back to the home screen. The only thing you ever do in that list mode is put the lists in, the data values into the list. Once you're done with that, you've got to get out of it and go back to the home screen. And we do that by hitting second mode. I'm going to quit writing that down because we do it all the time now. You should be getting good at it. I'm sorry. Now we're going to do our mean for our grouped data. What do we hit? Stat. Go over. Let me pull up my other one. We hit stat, and then we scroll to the right to calculate, and we want to calculate the one variable statistics, where now my data is in list 1, so I hit second 1, and my frequency list is list 2. I hit second 2. and then scroll down to calculate. If your screen doesn't look like this and you just see one variable stats on your home screen, you're going to have to hit second 1, comma, second 2. Then we calculate, and this is what we get. It looks like there were an average of 137 text messages sent. The mean is going to be this number right here. When we multiply the mean by the frequency, what we're doing is we're saying we have 10 of these 25s, we have 5 75s, we have 13 125, so forth and so on. So that gives us all of the data values. The sum of, when we add them up, it gives us the sum of all the data values. I'm not going to take you through the steps to calculate this by hand because you don't have to. We're going to use the calculator to calculate the mean for a frequency distribution. There's a lot of things that we went over in this section, and you may have to review this video just to keep it all straight. We learned how to compute and interpret the mean of a data set, the notation for population and sample. This was review. We already knew this. Population was mu, sample mean is x bar. We learned how to compute the median, how to do this on the calculator. We learned what resistant means. Which one of the variables is resistant, the mean or the median? The median, because it's not changed by one extreme value near as much as what the mean is. The median is resistant. The mean is not resistant. If your distribution is symmetric and bell-shaped, what do we know about the relationship of the mean and the median? They're the same, right? The mean is equal to the median, and the x with the tilde over it is what we use for the median. If your distribution is skewed right, and which one of these lines here would be the mean and which one would be the median? If your distribution is skewed right, what's going to be pulled to the right, the mean or the median? The mean gets pulled by the tail, the median does not. If your distribution is skewed left, the mean would be to the left and the median would be to the right. X with the tilde over it is what we use for the median. And we talked about the mode of a data and then how to calculate the mean for group data. Any questions about any of this? Then this wraps up section 3.1.